Now I can only stay there. You know, I can stay stadium.
What are the difference? Okay, social media. There's no difference. Are you sure? Are you sure? Somebody want to fail. Oh. They will not answer. I pray they will not answer such question. You tell them it's the same thing. I'm asking you, asking me. Yeah, I know there's a difference, but I don't know the difference. So I'm. Right. Speed of sound wave in a media is given as
Social media.
you have your V is equals to F lambda. Lambda, yes.
Your lambda looks like how
Look like what? Who is the owner of this pen?
So that it should be pen. It should be pen. Size is pen.
Please, less the noise. Less the noise. What is F? F is what? Frequency here is what? Nobody should tell me C Oliver Lambda. Hope nobody will tell me C Oliver Lambda. If you tell me C Oliver Lambda here, you are lost too. Where T is what? What's the difference between this time and this?
After this period. Small T does time.
What's the period?
So net capital is like related to oscillation. Related to oscillation, that is like the period. But white time is in seconds, it's not related to it. It's just
Thank you very much. Thank you very much. Right, the speed of sound. You are making noise today and I don't like it. Should we stop the class? Right. The speed of sound is directly proportional. The speed of sound is directly proportional to the square root of the absolute temperature, theta. To the square root of the absolute temperature, theta. That is V, absolute temperature, theta. That is V is equal to theta. Somebody asked that is temperature involved in sound?
Yes, now.
Can you give us an explanation to that?
Okay.
Like now, okay, you want to say something. Say what you want to say.
What I want to say is like,
Hello. In propagation of sound wave, don't write, I'm just explaining. Like sound wave traveled far at night as compared to day. Far at night as compared to day. It has to do with the ionosphere. When you go to radio wave propagation, you go deep in physics. You understand those? Let's not talk about that. It's the charged part of the atmosphere. But what? So, but in a case where you're having When you are having two temperature, in a case, you can write you say okay, that's temperature and velocity. Yes. You are giving two value of velocity, you're giving two value of temperature. You can use this formula. So take note. You know we are not taking examples because we want to say I can cover this topic today. Today.
So I'll give us just two examples. Just two.
We are moving fast and I love that. Echo. Echoes or echo. We are moving, we are still under the sound, right? Now when you are in an empty house as a young boy, hello, as a young boy, you are living with your friend before and you were able to get money to rent a house, right? As at the time of you renting the house, when the room is empty and you are talking, you see there will be a reflection of your sound. What is reflection? Echo is reflection.
Ah, good.
You are using your time to play. I'm not the one. I'm not the one that is writing down. And that's what I'm saying. It's part of it. So, right. Like any other wave, sound wave can be reflected. So an echo is the sound heard after a sound. Like any other wave, sound wave can be reflected. Reflected. An echo is the sound heard after a sound wave has been reflected. An echo is the sound heard after a sound wave has been reflected from a hard plane surface. Full stop. The sound heard after a sound wave has been reflected from a hard plane surface. From a hard plane surface. Don't make noise and you will hear me. Hello? Sorry. I'll dissolve your gathering here and I'll send you out of the class. I'm very serious. Please. If you don't want to learn, you can just keep quiet and be doing whatever you're doing. I don't have any challenge with that. Like any other wave, sound wave can be reflected. An echo is a sound heard after a sound has been reflected from a hard plane surface. Time taken, full stop. Time taken for an echo to be heard in any medium. Time taken for any echo to be heard in any medium. T.
Time taking.
Yes. Time taken for an echo to be heard in any medium. T. Time taken T is equals to 2x all over V. Where x is the distance and v is the velocity. You can write where s is the distance and v is the velocity. Full stop, right? If two distance, you can't hear me. People are making noise. There's no way. People around there are making noise. Tell them to keep quiet. Please, can you lower your voice even if you want to talk? Time taken for an echo to be heard in any medium is given as t is equals to what you have on the board. Then right. If two distance and two layers are involved, if two distance and two layers are involved, two distance and two layers are involved with respect to time, we use the formula x2 minus x1 VT2 all over 2 minus VT1 all over 2. Are we together? If we factor this, what are we going to have? If we factor this, what are we going to have? V T. Did you say T? V. Should I put bracket? T2 over.
Okay, sir. V over 2.
Eh? V over 2. Is it like this? Is it correct?
Size emperor, you believe him.
Stop making noise. Stop making noise. Stop making noise. Stop making noise.
Who are the hosts?
It's the same thing, right? The other one too is right. If you multiply this, V all over 2 multiplied by this, you have VT2 all over 2. Still multiply, still get the same thing. The first one is not correct. Is the first one not correct? So from here we'll be having what? S2 minus S1, right? Is equal to what? V T2 minus T1 all over 2. Now, from here, any problem you are being given, either x1, x2, either v2 or v1, just know where we're coming from. You should be able to solve them. You can even decide to solve this, you have the value, solve this, you have the value. Then the value of s1 you minus from s2, then you apply. I'm so sorry we are not taking examples. I'm going to take examples, don't worry.
What's your stress?
Now, please be noting all this formula. I'm just introducing you to formulas so that you can apply them. Is that okay? I'm introducing you to formula so that you can apply them. So let's look at velocity of approach. Can I wipe this?
Yes, sir. I know, sir. I know, sir. No worry. But me, I summarize you right now. See, no, you know, same thing. You know that first one way, right? Second way for same thing. I need to do that for right program.
Velocity of approach. Velocity of approach. Velocity of approach is equal to the distance between the echoes and time interval between the echo. Imagine I can say hello and the hello is coming so many times. So you are hearing hello, 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 and the hello is going. You say hi and the hi is coming. Hi, hi, hi. So it is the distance between the echoes and then the time taken between the echo. When I say hello, the first echo, at what second did he arrive? The second echo, at what time did he arrive? Is that okay? If you are given this a different distance, you multiply them with what you are having here. Time interval. Is that okay? Let's look at vibration of strings. Are we fast? That's what we don't have time.
Slow, we are slow. We need to eat off. They obviously take it like that.
They say we should use lecture method. We should not use the normal teaching method. Example 1, example 2. They we don't have time. We are having lots of topic to cover. Vibration of strings.
Vibration of strings.
Under it, fundamental frequency. Fundamental frequency.
Vibration of strings under it.
Fundamental frequency, comma. Vibration of strings.
Fundamental frequency.
Fundamental frequency, harmonics, and overtones. I know you've heard of all these things. Overtones, overtones. Write over, then write tones. Okay, I say vibration of strings. Under it we have fundamental frequency, harmonics, overtones. This is the spelling for the fundamental frequency of a vibrating string. The fundamental frequency of a vibrating string. The fundamental frequency of a vibrating string is the lowest possible frequency. Is the lowest possible frequency that can be obtained from a plucked string. Lowest possible frequency that can be obtained from a plucked string.
Possible frequency that can be obtained.
From a plucked strings. String. When it vibrates in a single loop. When it vibrates
In a single loop.
when it vibrates in a single loop or loop L-O-O-P.
In a single loop. Why not?
Can we continue? When it vibrates in a single loop. Are we still going to do wave? Is there any need? Is there anything in wave that we need to do? We'll do it, don't worry, we'll do it. Are we together? Are we together? Are we together?
Yes, sir.
Now, we're talking about a single loop. This is a good example of a single loop. Now we are having two loops here. What's the wavelength when it comes to wave? Your wavelength, what's the definition of wavelength? Is the distance what? Or 12. Refraction and is it and compression, right? Okay, what's refraction?
Let me try.
Refraction. It's not refraction.
Ray.
What's refraction? What's refraction?
Refraction. It's like
It's not refraction.
refraction.
It's not refraction.
Rare.
Stop that.
Refraction is different from refraction.
Yes, refraction is the bending
Yes.
of a ray as it passes from one medium to another. Now, refraction now under wave.
Refraction is like in a spring. When a spring is compressed and released, like as how like explain, but I don't.
Yes.
You get one.
He knows what he's saying. He knows what he's saying and he's right.
Don't feel me. Stop lying.
From the word compress. Now, this is a single loop, right? Now, if you have your wavelength, it's going up and down, right? We just decide to remove a single loop, which is this, right? And now this single loop, the wavelength of this single loop is being given as lambda all over 2. We are talking about what? Fundamental frequency, harmonics, and overtone. Bring your head home. Don't rest so much on wave at the beginning. Is that okay? And we're talking about a single loop now. This is the length. The length of this is what? L is equals to what? Lambda all over 2. Is that okay? Now our lambda will be given as what? Lambda is equals to what? Is that okay? Is anybody confused?
No, sir.
Is anybody confused? This is a single loop. So, talking about what did I say is the fundamental frequency? Please, if you are not careful, I'll start sending some persons out of the class, and I mean it. We say our fundamental frequency is the lowest possible frequency. So, at the lowest possible frequency, F naught, the lowest energy level is E naught, right? The lowest possible frequency is F naught, right? And F is equals to what? Formula for F, okay. Lambda is equals to what? V is equals to what?
Lambda.
So F is equals to what? Right? So where F is equals to V over lambda, our lambda is what? So at F naught, we'll be having V all over lambda, and our lambda is equals to what? 2L. This is the fundamental frequency for this single loop. Please get the understanding. This is the fundamental frequency, F naught, for this single loop. Is anybody having any challenge with this explanation? Can I move forward?
Yes, sir.
Now, right. Harmonics are frequency which are whole number multiples. Which are whole number multiples of the fundamental frequency. Whole number multiples of the fundamental frequency. Multiples of the fundamental frequency. Now let's take a look at two loop. Can I wipe this? Somebody say no. Let's take a look at two loop. L. Between Can you see this? Can you see this? Now we are having what? We're having 1, 2, 3 node. You know the difference between node and antinode? Eh? Do you know the difference between a node and an antinode? What's the difference? Eh? This is an antinode. Yes, an antinode. So if I should wipe this, everything is open, it's not closed, right? So here becomes our antinode. Don't worry, we'll still look at. Don't worry, we'll still get there. When we get there, you understand. We start having law. We are having a lot to do. So from here, you can see we are having how many nodes? 1, 2, 3. So the distance between what? 3 consecutive nodes is lambda, which is the wavelength. And therefore, our lambda will be equal to L. 2 successful crests and 2 successful troughs. This is what we are having on the board. So this is wavelength. But the other one we are having what? Half. That half is half of the wavelength. This one now is a complete wavelength. Thank you, sir. You want to ask a question? Which of them? The first one is a complete cycle. But is it distance between 2 successful crests?
No.
You understand? Is it a distance between 2 successful troughs? But this is a good definition of that. You have your crest, you have your trough. Is that okay? Can we move forward? Now let's go to. So from here now, our V is equals to what? V is equals to what? F lambda. Right? F will be equals to what? V over lambda, right? Where lambda is equals to L, it will be equals to what? F will be equals to V over L. Is that okay?
Yes, sir.
This is at F naught. Fundamental frequency. You see? Yes, we are dealing with harmonics. As we are dealing with harmonics, we'll still be talking about the fundamental frequency. We'll also be talking about the harmonics and the overtones together. So their formula will be joined. But just try and get the understanding so that you not be confused. Know what your fundamental frequency is. Know what harmonics is. Know what your overtone is. Is that okay? Sorry, I want to correct something. Now this will be F1. First harmonic, second harmonic, but first overtone. Okay, let me write it here. First overtone. Is that okay? Thank you very much. Is that okay?
Yes, sir.
Please just be following. Try and understand. Ask your question, please. You don't want to ask the question? Should I explain it again? Now, from the first one, we'll say we are having what? 1, right? Just 2 nodes. Here we are having 3 nodes. and we say the distance between three consecutive nodes is wavelength, because wavelength says the distance between two successful crests or two successful chop, right? So we are having our crest and our chop here. Is that okay? That's the reason why we are having this. And then we say the length, this L, when we are having one, it is half. This is 1 all over 2, right?
Yes, sir.
This is 1 all over 2. 1 all over 2 plus 1 all over 2 is what? Is that okay?
Yes, sir.
That's the reason why we are having one wavelength here. Or you want me to write it one wavelength? Hello. Just be thinking about the question and interpret it.
He said the rhythm
The third harmonic or second overtone, right? The third harmonic or second overtone is obtained when the string is plucked and made to vibrate in a tree lobe. Is obtained when the string is plucked and made to vibrate in tree loop. Now, in the first, we're having a single loop, double loop, and we're going to be having tree loop now. And each loop is one harmonic, right? We'll be having our first harmonic here, have our first harmonic, second harmonic, and we're having another one now, third harmonic. Let's look at the diagram. Can I wipe this? Draw yours very well, oh. You said what? Somebody should read for them if you have gotten it. Read for your colleague, read for your neighbor. Excuse me, are you even following? Sorry. What happened?
When I remove that phone.
Is that okay? Hello? 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 Now we are having how many harmonics? How many harmonics are we having? This first, this second, this third. How many overtone? 2 overtone. Is that okay? 2 overtone. Now, our length here is being given as 3 lambda all over 2. Do you know how we got 3 lambda all over 2? Do you know how we got 3 lambda all over 2? You don't know? 3 divided by 2 is what? This is a complete wavelength. L is equals to what? 3 lambda all over 2. So our lambda is what? You said what? Is that okay? Can we move forward? Who is saying no? We're having 3 lambda all over 2, right? You say 3 lambda all over 2. If you are dividing through, you have 2L. For you to make lambda to stand on its own, you divide through by 3. You must not be doing all these things, please. Hello. Now, if I were to impute this in our formula, we're having second overtone and what? Third harmonic. F2 V all over what? 2L all over 3, right? Which is also equals to 3V all over 2L. Is that taken?
I don't understand.
The fundamental frequency is half, right? Okay, 2F naught. Yes, we are getting there. As I did the example, as if you have seen something like that. Thank you. You are getting the understanding, small. So as we are going now, you don't have challenge with that again. So from here, we have our F2 to be equal to this. Now listen. First overtone, second harmonic. You have F1 is equals to 2F naught, which is equals to V all over L. This is what you are saying. Then you have second overtone, third harmonic to be equals to F2 is equals to 3F naught, which is equals to 2V all over L. So also the third overtone and fourth harmonic will be equals to F3, which is equals to 4F naught. Sorry.
Yes, sir.
3F naught. What we're having, you just finished solving this. Sorry. 3V over 2L. Then the fourth. V 2V over L. Can we move forward? Ahead.
Yes, sir.
Like that. Please take note of all those things, all these things. Take note of all these things. First harmonic, we have V all over L. Second harmonic, second overtone. First overtone, second harmonic, F1. Second overtone, third harmonic, F2, which will also give you 3F naught, and it's 3V all over 2L. Nobody should ask me that how do we get this 2L? We just solved it here now.
Yes, sir.
So, are you following? Do you understand? Where are you having challenge? Two, how do we get 2 lambda over 3? Where is 2 lambda? Is it, where is the 2 lambda? 3 lambda over 2.
Lambda is outside.
This is 3 lambda over 2. You understand? Are you sure? If you don't understand, tell me.
Salon Mendes. I in the head. You don't understand.
What's the time? What's the time?
What's the time? 10:15.
Someone has a question.
Question.
Why is it 2v over lambda over L in this F3? Somebody should answer the question. The person she's answering is hearing. Do you understand? What she's trying to say, the lady asked a question. Yes, that's what I want to answer. Is that okay? She asked a question that, why is it that the third overtone and fourth harmonic, we are having 2V all over L? Right? 2V all over L. In the fourth harmonic, they have permitted me to send some persons out of the class. Hello? And I will not hesitate to do that.
Yes, sir.
And I will not hesitate to do that. If you don't mind yourself. If you don't mind yourself, I will not hesitate to do that. Now, in the fourth harmonic and third overtone, you'll be having another one here, right? Are you seeing?
Yes, sir.
Another harmonic will be added. And when this harmonic is added, you are having 4 harmonics.
Yes, sir.
Is that okay?
Yes.
And we say 2 harmonic is a lambda, right?
Yes, sir.
2 harmonic is also another lambda. So you're having what? 2 lambda, right? L is equals to 2 lambda. So lambda now will be equals to what?
2 L over 2.
L over 2. Is that okay?
Yes, sir.
And then you are having your frequency to be what? V over, and your lambda is what? It will give you what? If you like, say 2V over lambda. Can we move forward?
Yes, sir. Ahead.
Oh, you will soon be through with wave. Now let's look at sonometer.
Kilometer.
Sonometer.
Yes, sir. Small meter.
Factors affecting frequency of a vibrating string. Sonometer. Sonometer. Factors affecting string.
Frequency.
Factors affecting frequency of a vibrating string. Frequency of a vibrating string.
Sonometer.
Right. The frequency of notes. If you have to write frequency, you can denote it with F. Or you write short form, frequency. Since we are dictating to save time. The frequency of notes acquired from a string instrument.
Upload acquired from a
Notes.
string
S.
glory.
Notes. We are the musician here. Those that play keyboard. All these things we are saying, you should be familiar with it. You should know what is harmonics. You should know what is harmonics. You should know what is tone. What is tone? A distance between what? Yes.
Eh?
What is tone?
And you are
For those that are studying music, there's a definition for tone,
yes, sir.
right? We have tone, we have semitone, right? And we are doing the physics behind the music. So when you are getting your formula, they'll tell you tone, tone, semitone, tone, 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 semitone. That is how you get your soprano, do, re, mi, fa, sol, la, ti, do. Let's move forward. Let's move forward. The frequency of notes acquired from a string instrument is studied with the help of a sonometer. With the help of a sonometer.
Acquired from a string.
Example of string instrument.
Guitar.
Violin. Harp. Harp is wind instrument. Flute is wind instrument. The one that David plays, is it a harp? According to the book of Bible story. Okay. The frequency of a vibrating string, right? The frequency of a vibrating string of tension T. Ola.
No, sir, I wasn't the one that started this. Sir, they started straight by squeezing me ice block from that side.
I'll send you and the person now.
Sir, I didn't do anything.
I've always asked you to be quiet in the class.
I was writing. Get up, one more block.
The frequency of a vibrating string of tension T.
Of tension.
Length L. And mass per unit length M. Mass per unit length M. Capital M. Vibrating strings of tension T, length L, and mass per unit length M must obey the following laws. Must obey the following laws.
And mass. Mass per unit length M, sir.
Yes, M.
Why this one is blue box, sir?
Constant.
That fool, what that fool says. You buy that fool.
Please stop playing with the block.
Sir, this is already. Yeah, I'm getting this. They are not like this. They are like this.
After I go, give you that block.
One all over L dot T. One all over M.
So you're not directly proportional.
Which of them?
The first one. After comes
At L and M. Thank you. Is the first one?
after T and what?
M.
M.
Toby, I know you not follow the class.
Yes, sir.
You are trying. There's no way you cannot be at the back and follow the class. If some persons that are at the front cannot follow, if they are sitting at the back end, now if you combine these two relations,
Combine.
the tree relation, you have f will be proportional to 1 all over L root of T all over M, or K all over L root T all over M. Right, the velocity of a wave
The velocity of the wave.
the relation. I just write combine 1, 2, 3.
The velocity of the wave.
Yes, sir. The velocity of the wave.
What's the time? Which time?
10:28.
We are supposed to cover 2 topics and we have not covered 1. Toby, we are supposed to cover 2 topics and we have not covered 1. We are supposed to cover 2 topics and we have not covered 1. Oh, we are not through with 1. Please, let's be fast so that we can be able to cover it. So when you go home, you look at the examples, you hammer them. Anyone you cannot do, you bring it, we do it together. Yes, we don't have time. If I'm to give you examples, we will not even reach half of the topic. And we are supposed to cover 2 topics. Don't worry, I'll bring examples for you.
Yes, after 3.
I'll bring examples for you. Right. Velocity of a wave propagation along a string.
Velocity of the wave propagation.
Velocity of a wave propagation along a string.
Along the street.
Along the string.
Depend on its tension T. And its mass per unit area. So the velocity is given as v is equals to root t all over m. V,
I say so what?
mass per unit length. We say m is mass per unit length, right? Velocity of a wave propagation along a string depend on its tension T and its mass per unit length. So V, our V will be equals to root what? T over M. Where T is what? Tension. And M is what? Per unit. Thank you very much. Somebody is saying no. The L has disappeared. The L has been compressed in the mass. So if they are going to give you the value, they will give you in one. They will tell you who is having a mass per unit length of so don't be confused and start looking for L. Is that okay? Now let's still go through this. Can I wipe this? F naught. F naught is what? F naught is what?
Say this man only is stop now.
Right? At
Yes, sir. Stop making noise. Stop making noise.
Two F naught.
Vibration of air column in pipe. Vibration of air column in pipe.
So I just like this one.
Whether you like it or not, you cover. Whether you like it or not. Yeah. At F not. At. Sorry. Thank you. Vibration of air column in pipe. Ma.
Vibration.
Vibration of
Well done, right. Vibration of air column in pipe. Air column in pipe. Is that taking? You said what? Can I continue? Vibration of air column in pipe. Right. Air column can be made to vibrate in closed. Air column can be made to vibrate in a closed pipe or enclosed pipe, comma, open pipe, or in a resonance tube. Air column can be made to vibrate in a closed pipe, open pipe, or in a resonance tube. What is resonance? What is resonance? What is resonance? Tell me, what is resonance?
Let me try. Like forced vibration.
Fourth vibration. Fourth vibration. Like lie.
No, forced like vibration.
Right. Vibration in a closed pipe. Vibration in a closed pipe. When air column vibrates in a closed pipe, air column vibrates in a closed pipe. A node N is always formed. A node in a closed pipe, a node N is always formed. Okay, a node. Is always formed at the close end of the vibration.
Close end of the vibration.
While antinode is formed at the open end. While antinode is formed at the open end. Some of you that used to play be carrying what is happening open, be some of these children, they'll be carrying a pipe and they'll be making noise. I know many of you have done it. So now this is having a close end. So in this case, see now, who made that sound? Yes, he's still doing it till date. Copy from your colleague, please.
So I see my comrade again.
It's okay. We have learned. We already know what it is now. Like a cover of a pen now is an example of a closed pipe. Because whatever sound you are making is not going through. Right? Is that okay? So we want to look at the kind of vibration and the wave that is going to produce. Is that okay? So let's look at this diagram carefully. You're having a closed pipe. It's coming like this. This is your what? Antinode. Is that okay? Now, if you're having a harmonic as this, right? What we are having here is the half of a harmonic. And this half now, I told you the other time that here is your antinode. When you are wiping this, totally. Do you understand? So here you are having your node. And this is given as lambda all over 4L. Have you seen the length?
Yes, sir.
Do you know why it's lambda all over 4L? You know why, right? You don't know why? It's foresight. You don't know why it's lambda all over 4L?
Sir, we know.
All over 4.
Yes, sir.
You divide this into 2, right?
Yes, sir.
You are having another one. For you to get a complete lambda, you need 2 of these. Right? This is what? 1, 2, 3, 4. Is that okay? Is that okay?
Yes, sir.
It's 2 harmonics that gives you a wavelength, right?
Yes, sir.
Then when you divide the harmonics into 4, is what you're having here. So we need 4 of these to get a wavelength. Is that okay? So from here, our please stop the noise. Stop the noise. I'll send you out to. Just drop it and go to your seat. If you will help you, will help you charge it. If you not help you charge it.
Baba, why you go for a farm?
I'll pay 5 each.
You pay 5 each. Now pay for service. I didn't do service for payment.
But you block this one.
See, after a favor, 200. I don't joke. No, don't give me the money now like this.
Stop making noise, please.
Send him out. Yeah, see.
I did one.
Baba, if you need it now, my stress really come out. All of the sudden, I'm going.
That's our price.
They will see lions.
It's okay, go back.
So they are born to something. It's like
That's how I'm going like that.
you don't need it.
How far you try to wait? Suck never move quickly.
Ola, did you feel this? Did you feel it? Help us feel it if you can.
Okay.
Okay, there's no ink.
Yeah. Finally.
Charging phone and corner seats. Oh, this. Don't need to.
Label this as F naught, F1, and F. By now, you already know the meaning of
Look up, Nana, I don't
Johnny. You don't like me too. Like copying me. Why they copy me?
V is equals to what? We need marker. They say there's no ink.
Let me see one check.
What do I do now? Use this. Get your L. Find your F naught. Use this. Get your L. Lambda is equals to what? Then you have V is equals to what? V is equals to what? F is equals to what? V all over lambda. So when you get the value of lambda from these three, impute it. And you get for F1, you get for F2, you get for F3. Let's do it. So when lambda when you're having 4 all over lambda here, your L is equals to what? L is equals to lambda all over 4. Lambda is equals to what? So be understanding? You don't understand? Yeah. Here we're having the wavelength is 4 all over lambda all over 4. Do you know why? Eh? You did not ask. It's because of Toby I'm stressing my breath like this. The reason is because one harmonic, right? The one that is like this. One harmonic is half, right? And we need 2 harmonics to get a complete wavelength, right?
Well, I think that those one get to.
No problem. I mean, they use English. Having technical issue. So, our having the wavelength, right? This harmonic now is the half of it we are having. So, how many of it do we need to get a complete wavelength? How many half of the harmonics do we need? To get one wavelength, how many half do we need? If this is a harmonic, this one harmonic, right? And we need 2 of it to get a wavelength, right? And now we are having something like this. This one, half of the harmonic, right? So how many of these do we need to get a wavelength? It's 4. That's the reason why we are having lambda all over 4. Same thing apply here. Same thing apply here. So calculate. What we are doing now, you have gotten it. Okay, what you will do, you say that V is equals to what? F lambda. So F is equals to what? V all over lambda, right? At F naught, you have what? Your V all over lambda now, you come here, you pick this. This is F naught, F1 and F2. You pick this, you say L is equals to what? Lambda all over 4, right? Then you now have what? Your lambda is equals to what? 4L. Is that okay? You carry this. When you are having F naught, you write V all over. Your lambda at F naught is equals to what? 4L. Do the same for F1. Do you understand? You do the same for F1. Baby, do you understand? You do the same for F1, do the same for F2. So if you are looking for F2 now, V all over our lambda from here, we are having 3 lambda all over 4 is equals to L. We are having what? 4L over 3. So you carry this is equals to lambda. You bring it here. 4L over 3, which is also equals to what? 3V over what? 4L. Sorry, this F1. Do you understand what we are saying? Do you understand? You sure? People are making noise. How will you understand? People are making noise. Please, I beg you in the name of God. I beg you. If you don't want to learn, allow others. He's begging and begging. Can I wipe this?
Yes.
So the F2, this is F2, right? We are having L is equals to what? 5 lambda all over 4. Is that okay? 5 lambda all over 4 now. You say you are having what? 4L. You'll be having 4L. Sorry. Is equals to 4L over 5 lambda. Right? Who is saying you're not saying? We say we have L equals to 5 lambda all over 4. Right?
Yes, sir.
You'll be having what? 4L is equals to 5 lambda. Right? So your lambda is equals to what? 4L over what? Wait, lambda. You remove this answer, 4L over lambda. You impute it in your word. F2. Right? V all over what? 4L over 5, which is equals to 5V over 4L. Note this. You know the formulas are different when it comes to open pipe and the other one we've been doing before. Is that okay? If you go to the previous one. So if you are being asked any question, listen carefully. Read the question and understand it. If they are talking about open pipe, if they are talking about closed pipe, if they are talking about harmonics or normal overtone on the string, we're talking about open pipe. Sorry, we are talking about closed pipe. If you see the end is closed, is that okay? See the end now is closed. When the vibration comes in, it goes out. But if it were to be open, it will be continuous. And at the end, you are going to have 2 antinodes. Is that okay? Amaka, what's the time? From our last class, people are owing me so much time now. So F3 will be equals to what from here now? F3 will be equals to what? F3 will be equals to what? 7 lambda over. No. What are you telling me? 7V or 7 lambda? Is it 7V or 7 lambda? 7V all over what? You are going to add it. It's a diagram. Just but make sure you understand it. That is how it continues. Now let's look at vibration in open pipe. Vibration in open pipe. People are not writing. So you just left your house, you come to this place to relax and gist.
Sir, what do you say?
Vibration in open pipe.
Vibration in open pipe.
When a column of air is vibrated in an open pipe, when a column of air is vibrated in an open pipe, the stationary wave,
Okay.
the stationary wave form along
Sir, please come again.
when a column of air is vibrated in an open pipe, the stationary wave form along have antinode at the open end. Have when a column of air is vibrated in an open pipe, the stationary wave form along. Sorry, it's not along. I just have a challenge with what I wrote there. The stationary wave form always is not along. Always have antinode at the open end. Always have antinode at the open end. You did not come to class today, or you just coming? Thank you. You are welcome. Okay, let me use this as an example instead of wasting the marker. This is what they are saying. This is what they are saying. This is what they are saying. This is the waveform. We are having antinode at the beginning and antinode at the end. Is that okay? This is for open pipe. Jam may want to give you bonus and will ask you, which of this diagram is open pipe? Which of this diagram shows a vibration in an open pipe? And you go and shows the one they close up and close down. Okay, Oyo is your name. You are on your own. So please understand this. In an open pipe, the two end antinode will always be formed. Is that okay? Is that okay? Let's take a look at the diagram. Oh, this one will not have a marker. Okay. This is your F1, F0, F1. You have attended to the technical issue, right? Thank you very much. This is what? The length is going to be equal to what here? Science student. The length here is equal to what? The length here is equal to what? Where is lambda over 2? Here is lambda over 2. What about here? Lambda. Wavelength should not be a challenge to you now again. After knowing that wavelength is distance between successful crest, distance between successful chop, after knowing that wavelength is two harmonics, wavelength should not be a challenge to you again. Now, calculating it. They should give you a diagram. You should know how to bring out your wavelength. That shouldn't be a challenge at all. What I'm drawing and what people are drawing are different though. I don't understand, you understand. How do you understand it? What I'm drawing is different from what you are drawing. See your own even.
When I see question,
This is not how I've been drawing it. So people are just putting cycle in the vibration will touch the two walls of the pipe. L. The length here is what? Lambda And the length here is what? Okay. If we're having for the F2, yes, this is the last diagram I'm doing here. I think we are through with okay, let's do this last diagram. The marker is not writing. Draw it on your own. Draw it on your own. This is a third diagram. This is how it looks like. Draw 3 lambda over 2 in an open pipe. That's exercise. Draw it. 3 lambda over 2. Is that okay? 3 lambda over 2. How many harmonics is that? 3 lambda over 2. How many harmonics is that? 6 harmonics. 3. Is it 3 harmonics and 2 over 10? So draw that and solve. Yes, it's time. I'm just trying to give some persons exercise. If you want to go for a break, you can go already. It's time. Is that okay? You go for your 15 minutes break and you come back. Now, you find for your F0, right? F1 and draw the one for the F2. Who is saying I don't know? Don't you like this method? We are almost through with this. We are almost through with the sound wave. I'll try and get few examples for you to practice.